Hi everyone, welcome to today's math session where we are looking at a City and Guilds past paper. There is a link in the description where you can get hold of the past paper, but otherwise I'm going to display all the questions on the screen anyway, so you can just follow along with me. Okay, right, let's begin. So, here we go, we've got question, we've got the first page per here, so 25 minutes for this first section, so I'm going to keep an eye on the time and hopefully we'll get that done within 25 minutes. Remember, the first section is non-calculator, and then here we go. So question 1, what is 531 times 1.4? Okay, so I'm actually going to think, I'm just going to do this using a method. So I'm going to use a grid method that I like to use, called a lattice method. So I'm going to put 5, 3, 1 here, 1, 4 here, and the way that this method works is you multiply everything together, putting the tens in the top part and the units in the bottom. So this first one is 1 times 1, so I'll put a 0 there and a 1 there because that's 1. Then I've got 1 times 4, so I'm going to put a 0 here and a 4 here because 1 times 4 is 4. 3 times 1 is 1. No, it's not. 3 times 1 is 3. So I'm going to put a 0 here and a 3 here. 1 times 5 is 5. So I'm going to put a 0 here and a 5 here. 3 times 4 is 12. So I will put a 1 here and a 2 here. And then 5 times 4 is 20. So I'll put a 2 there, a 0 here. Now what I've got to do is I've got to add up along the diagonals, okay? So let's go from this side, because we always do that in case we get enough of either like a unit which qualifies it to be a 10, or we got enough 10 so they move over to the hundreds. So let's have a look at this. So we've got 4 by itself here, so 4 is just 4. 1 add 0 add 2 makes 3. 0 add 3 add 1 add 0 is 4. 0 add 5 add 2 is 7. And 0 is this. So I know that this is going to be 7, 4, 3, 4. Now what I need to do is work out where the decimal place goes. So the decimal place was here. I technically did here 531 times 14. So what I need to do is I need to divide this all by 10. So the decimal place is going to go one space in. So the answer to this would be 743.4. So let me write that here. And I've also got the mark scheme up for this because I started doing this recently. I do like to check as I go along because I am prone to making mistakes from time to time. So let's have a look here. And we've got this, yep, 743.4. So the mark scheme agrees. Wonderful. Okay, let's just reposition my microphone. Right, let's go on to the next question here. So question 2 is, what is 5 to the power of 4? Okay, so this means 5 times 5 times 5 times 5. So here we go, 5 times 5 is 25, times 5 times 5. 25 times 5 is 125. So we're left with 125 times 5. Okay, now 120. I'm going to split this up into 2 different ways to do this. I'm going to think about this as 100 times 5 plus 25 times 5. Okay, 100 times 5 gives us 500. 25 times 5 gives us another 125. So now I can add these together, and that's 625. So I'm going to write here down 625. Okay, perfect. Right, let's look at question 3. So here we go. Question 3 is the following drawing shows a parallelogram. Okay, and work out the size of angle A. So parallelograms are special because first of all, a couple of things to know about this question is that it is a parallelogram, which is a 4-sided shape, and 4-sided shapes have angles of 360 degrees. Okay, and also opposite angles in a parallelogram are the same. So this one here would be 110 degrees as well. Now, if we think about this, it's not really symmetrical, but if we think about the fact that this angle would be S as well, what we can think about here is, if all the angles in the parallelogram add up to be 360, because it's a four-sided shape, well, because it's just two combinations, oh, it was called A, of A and 110, that means that each of these things must total 180 degrees, okay? So what I can do is, I know that A plus 110 degrees equals 180 degrees, so I'm going to write that down here. A plus 110 degrees equals 180 degrees, and so I simply just need to do 180, take away 110, so 0 add 0, 0 take away 0 is 0, 8 take away 1 is 7, 1 take away 1 is 0, so A is going to be 70 degrees, and that would be 70 degrees as well, and that makes sense because these two now add up to 180, these two add up to 180, 180 add 180 equals 360, and there we go. So A is 70 degrees. Okay, next question. Which of the following works out to be the largest number? Okie dokie, so let's have a look. So first of all, we have got 3/4 of 8. So the way that we do this is, if you want 3/4 of 8, first of all we think about what 1/4 is. So if we think about the whole, so 4/4 equals 8. So 1/4 is that divided by 4. So I divide this by 4, which gives me 2. So 1/4 of 8 is 2. So I want 3/4. So 3/4, I'm going to have to multiply this by 3. Okay, multiply this by 3. So 3/4 of 8 is not 8, it's 6. Here we go. 6. So this is 6. Right, 2/6 of 12. So 6/6 equals 12. 1/6 will be 12 divided by 6, which will be 2. So 2/6 will be 4. Okay, so this one's 4. Ooh, this is going to be, it's probably going to be this one. 3/2 of 10. 3/2 of 10. Okay, so let me go through that. So 2/2, which is 2 out of 2, is equal to 10. Divide that by 2 to find out what 1/2 is. So 1/2 equals 5. Okay, then we want 3 of these because we want 3/2. So we times this by 3. So this one is going to be 15. And this last one here, we've got 3/12 of 36. Let's see if I've got some space over here. So 12/12 equals 36. That's the whole. 1/12 would equal 36 divided by 12. So that's going to be 3. And then we want 3 of those. So 3/12 would be 3 lots of those, which would be 9. So which one works out to be the largest number? It's this one here. So we can give a tick by C. I just realised I should be checking my answers as I go. Here we go, 625, 70, C. Yeah, very good. Well done. Well, I shouldn't really be congratulating myself there. But yes, perfect. Right. What is 52% as a fraction in its lowest terms? So 52% means 52 out of 100. And then we're just going to start halving. Okay. Half of 52 is 26. Half of 100 is 50. We can half again. Half of 26 is 13. And half of 50 is 25. 13 is a prime number and can't be divided anymore, so we have got this in its simplest terms. So there we go, 13 out of 25. Ooh, we've got a spinner. Right. 1 second here. So question 6 says, if a wheel is spun again, if the wheel is spun again, what is the chance of diamond being the winner? Ah, I see. So we're currently in a scenario where this wheel has been spun once, and it's here, and we've got here, it's pointing to the diamond. Okay, so now what we're going to do is the wheel is being spun again, and we want to know the probability that it lands on diamond again. So what I need to do is I just need to work out I just need to work out what the probability is of it doing. So we've got 1, 2, 3, 4, 5, what's that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, there's 12 different options. Only one of them is diamond. So the probability of diamond being the winner is 1 out of 12. Okay, right. Let's move on to the next question. Question 7. We've got... this is going to be... okay, it's an estimate one. Okay, right. Question 7 asks, we've got a circle here with a radius of 3.92. Okay, the radius refers to the line, the distance from the centre to the outside. So you can see that on this line. So what we need to do here is it says which calculation gives an approximate area of this circle. So area for a circle is, have a think if you remember it, it's pi times radius squared, okay? Which is pi times radius. Now, pi, we normally use it as 3.14, but this question's asking for an approximation here. So I'm going to say that pi is 3, okay? This here says that the radius is 3.92. I'm going to call that 4. So 3 times 4 times 4, which is equal to, well, all of these have 3, so with the 3's right, we've got to work out what this 4 times 4 is. So 4 times 4 is 16. Okay, so the approximation for this one is going to be C, 3 times 16. Okay, let's move on. Okay, so here we go. What we've got here is we've got question 8, and question 8 says 8 take away 4 squared divided by 8 equals whatever. So we've got to work this out. So remember, 4 squared means 4 times 4. When we put the 2 up here, it means you're multiplying that number together that number of times, okay? So 4 times 4 equals 16. So now we've got to do 8 take away 16. Well, 8 take away 16 equals negative 8, okay? So the top bit becomes minus 8. The bottom bit becomes 8. Minus 8 divided by 8 equals negative 1. Negative 1. Okay. Question 9. Oh, we've got a graph. What are the coordinates of the star? Okay, let's have a look. So coordinates are always written x, y. Okay, which means we go, x first and then y. So this is the x-axis, which they've labelled. This is the y-axis. So let's have a read off this graph to find out what these are. So the x is up here, and that looks like it is a 5. The y is here, which looks to me to be negative 3. So is there a 5, negative 3? There is. There we go. Right. Let's continue. Ooh, it's a house. Nice. Right. Which of the following is the front elevation of the house? So, remember, the front elevation means all of the things that you see from the front. So, everything here, okay? And then this bit as well, because you can see that, even though it's slanted, you will see that. And you will see the front of this chimney. So, everything I've coloured in blue is what you can technically see from the front of the house. So we will have this little bit here. We will have the main body of the house. And then we will have the roof. And then we will have the chimney, which comes into the roof a little bit here. So it will look like that. And I don't think we won't be able to see the line there, but we will see those lines. So which one of these looks like that? Well, it is C. So that is our answer there. Okay, number C. Right. Just a bit of a just you know, if you need any work on any of these topics, all of these topics are covered in on the Crack Maths website, and I can quickly show you where they all are actually. So, oh no, right. So if you go to the Crack Maths homepage, and then go up here, we've got a bit that says resources, tutorials, and then we've kind of got all of these things here. So where would that be? Scale drawing, handling data. I think maybe I'll put that in here. How to make a scale drawing, how to recognize 2D shapes, how to connect 3D shapes with plans and stuff. Okay, so here we go. That is there. So yeah, and so we've got questions on these sorts of things if you wanted to do any practice of that. But let me get back to the paper. So here we go. Question 11. So question 11 is here. They're getting a bit longer now, these questions. So, but let's have a look. So let's have a look at how this is all going. So question 11 says, a commuter uses a bus and a train to get to work. The train is more than 5 minutes late 1/6 of the time they use it. The bus is more than 5 minutes late 3/5 of the time they use it. What is the probability that both the bus and the train will be more than 5 minutes late? Okay, so in order to do this, what we do is we just multiply the probabilities together. So we get 1/6 of the time here, and then we get 3/5 of the time here. So what we're going to do is just double check that I'm reading this correctly. So the train is more than 5 minutes late 1/6 of the time. The bus is more than 5 minutes late 3/5 of the time. Yeah, so we multiply these fractions together. So this is going to be 3/30. They haven't asked for us to simplify this fraction, so we don't have to. But just out of interest, this would simplify to 1 out of 10. Okay, so let's quickly we've gone through a lot of answers recently. Let's quickly check everything in the mark scheme. So there we go, 13/25, that was right. C, yep, -1, yep. Here we go, 1/10. Oh, ooh, you actually only got 1 mark for doing 3/30. I didn't see them saying in this paper that you had to simplify your answer, but they clearly wanted that. So there we go. They wanted you to simplify that fraction. That is interesting. Right, let's go on to question 12. Okay. So question 12 here, it says, a model maker wants to make a model of a ship. He will use a scale of 1 to 50. The ship was 100 feet long. 1 foot equals 0.3 meters. How long will the model ship be in centimeters? Okay, right, so a model maker wants to make a model of a ship. He will use a scale 1 to 50. The ship was 100 feet long. Right, so what this means is that 1 represents 50. Okay, so we know the ship was 100, so that will be represented by 2. So the boat, the model, is going to be 2 feet long. Okay, so we can see here that 1 foot is 0.3 meters. Okay, so if we've got 1 foot is 0.3 meters, we know that 2 feet will be twice that, which will be 0.6 meters. Okay, so how long will the ship be in centimeters? Well, 1 meter equals 60 centimeters. No, it doesn't. 1 meter equals 100 centimeters. Okay, so to go from meters to centimeters, we multiply by 100. So basically, we're going to do 0.6 times 100, which would be 60 centimeters. So I can write that down here. So we've got here 60 centimeters. Okay, great. Right, let's have a look at the next question. Oh, and this is the end of section 1. Oh, is it? Yeah, that's the end of section 1. Great, so we've done the non-calculator bit. Okay, perfect. Let me now get the calculator question, and we're making good time, so that is good news. Right. Okay, question 1. What is 12% of 5,300? Okay, right, so this is the calculator paper, so I'm going to use the calculator method for this. So let me just get out my calculator. Okay, here we go. I'll just put this over here. So the calculator method for finding 12% is to find your decimal equivalent percentage multiplier. So we just do 12 divided by 100 to turn it into a decimal, which becomes 0.12. I mean, we could have done that on the calculator. So 12 divided by 100 equals 0.12. Now, anything multiplied by 0.12 will give us 12% of that number. So we want 12% of 5,300. So we do 0.12 times 5,300. Here we go. And that equals 636. So there we go. So 1 second. So we do write down my working, 0.12 times 5300. And there we go. We've got our answer. Right. Let's have a look at question 2. So question 2 says, what is 23.3 times 0.463 to 3 decimal places? Okay, so I'm going to do this on the calculator again. So 23.3 multiplied by 23.3 multiplied by 0.463 equals this. Okay, so I'm going to write that number down. 10.7879. And we want it correct to 3 decimal places. 1, 2, 3. So we want these 3 numbers to all remain. Okay, so we've got to decide what happens with this 9. Is 9 closer to making... Well, we kind of look at this number, really. Is this 79 closer to being 80? Which if it is, we'll replace the 7 with an 8. Or is it closer to being 70? Which, if it is, we will just leave it as a 7. Well, 79 is much closer to 80 than 70. So we're going to just round this up. So the answer to this will be 10.788. Okie dokie, right. But let's quickly check a couple of those answers just to see how we're getting on. So here we go. Oh, that's good. We got 60 centimetres for that last one as well. So here we go. 636. Yep. 10.788. Perfect. So we are on the right track. Okay, question 3. Which one of the following lists is in decreasing order? Oh dear. Right. Oh, this is just a lot of calculating. Is there anything obvious to see first? Well, it's the same 4 numbers over and over again. So let's just work out what they all are as decimals. Okay, so where's my calculator? So here we go. Let's just... Oh no, sorry. Right, so let's just work all of these out as decimals. So the first one, we've got 315 over 100. Okay, so this one here is 3.15. Then we've got 1,500 divided by 924, which is 1.62. I don't think it's going to need to be that accurate. We've got this next one here, which is 200 divided by 57. So that's 3.5. Okay, and the last one we've got 3 2/7. So I'm just going to do the 2/7 bit here to find out what that is as a decimal. So this one would be 3.28. So I can see that the biggest one of these is this one. Then, so one which starts with that. So these two are in the running for that one. The second biggest is the 3.28. Okay, 3.28 is bigger than 3.15. So that's 3 2/7. Okay, right, so we've got our winner here. The decreasing order one must be this because it's the only one where the first two are in decreasing order. Okay, right. Let's move on. Okay, question 4. Okay, here we go. Let me just move this calculator out of the way. I'll put it over. Maybe I'll put it up here. Actually, I'm just gonna move it off screen slightly for the time being. Okay, so right, The question 4 says, the phone is £240 including VAT. What is the price of the phone before VAT is added at 20%? So, if we're adding VAT at 20%, what we're doing is we're starting off with 100%. We're adding our 20%, okay, which makes 120%. Now, remember about percentage decimal multipliers. What we need to do, if we want to find a percentage, so if we wanted to find 120% of something, which is increasing it by 20%, we've got to find our percentage multiplier so we know what we'd be multiplying it by. So to do that, I just do 120 divided by 100, and that equals 1.2. So now we know that the price... Okay, let me just move this out of the way. So the price multiplied by 1.2 equaled 240. So the price increased by VAT was 240. So now we just have to rearrange this calculation. Remember, if two numbers multiply together to give a third, we can find out the other one by doing the third number, which we call the product, divided by the other two. So I'm going to do 240 divided by 1.2, and that is going to give me my answer. So let me get my calculator back out. 240 divide... Oh, that's not 240. 240 divide by 1.2. Here we go. So the original price before the VAT was added was £200. Right, here we go. Let's have a look at question 5. So let me just move this calculator out of the way again. So question 5 says, the results for a local election were candidate 1, 602 votes, candidate 2, 553 votes, candidate 3, 350 votes. What fraction of the votes did the winner get? Give your answer in its simplest form. So we need to find out how many votes there were in total. So we're going to add all of these together. Okay, so let's do 602, add 553, add 350. Right. Oh no, I've gone wrong. That's 335, 350. Let's just double check these. 602, 553, 350. Find out what that is. So that's equal to 1505. Well, 15,005. Well, no, 1,505. Oh gosh. Right. So that's our denominator. What fraction did the winner get? So the winner got the most of those, which would be 602. Huh. Give your answer as a fraction in its simplest form. These numbers to me don't look like they have many common divisors. But let's see. What could they both divide by? Maybe they both divide by 7. Let's see. Does this divide by 7? Oh, it does. Right. That equals 215. 602 divide by 7 equals 86. They look like they might divide again. I know that they don't divide by 3. I know that because if a number divides by 3, its digits add up to 3. Maybe let's go with 7 again. I don't think 86 is in the 7 times table. Divided by 7? No. I don't know. One second. I don't want to leave this with being unsure. There's a method for finding out all the factors of a number, which is a prime factor tree. So we can do 82 is 41 and 2, because 41 times 2 is 82. 41, I know 41's a prime number. So 82 is pretty much, yeah, we're fine. This is it. 86 over 215. That cannot be simplified anymore, because I know that 215 can't be divided by 2. I don't think it can be divided by 41. Oh, 1 second. Sorry, I've gone really wrong. 86. So that's 43. Oh, they both divide by 43. 1 second, because let's just double check this. 215 divided by 43 is 5. Right, so this equals 2 over 5. Right, because both of these can be divided by 43. Divide by 43. That is a mean simplification that they're asking you to do there. But that's the answer, 2/5. It felt like when they ask you to simplify something that it usually can be simplified very, very much so. So let me just move that out the way. Okay, right. Right, question 6. Question 6 says, a parent fills in a medical form about her 2-year-old child. The parent measures her child's height with a tape measure and writes that the child is 3 meters tall. The receptionist at the surgery thinks that the parent has made a mistake. Yes, I think that the parent has made a mistake as well, because nobody is 3 meters tall. Is the receptionist correct? Yes. No one is 3 meters tall. Okay, there we go. That seems too easy as an answer, but let me go to the mark scheme to just double check. So here we go. 2/5, yeah, we got that. 200, we got that. Here, yes, and explanation. Why 3 meters not? The child would reach up to the ceiling, the child would be a giant. The parent misread meters for feet on the tape. Oh, that is what she did, isn't it? She misread meters for feet. Right. Okay, let's go back to the question. Okay, right, question 7. An editor needs to change the width of a photograph to fit in a magazine. Okay? The photo needs to be 32 millimeters wide. What percentage of the original width will the photo be changed to? Right, so first of all, let's get these in the same units. We've got centimeters here and millimeters here. I'm actually going to convert these both to millimeters because I think that's nicer than dealing with decimals. So the photo is going from 89 millimeters wide to 32 millimeters wide. So it's going to be reduced by a certain percentage. So our calculation for that is going to be 89 times the percentage multiplier will equal 32. Okay, so first of all, I can find out what this number is going to be here by doing 32 divided by 89. Okay, now this number is going to be our decimal multiplier, decimal percentage multiplier. So let's find out what that is, and then we can make sense of that. Whatever. Okay, right. So let me get out my calculator. So here we go. I'm going to move this onto the screen. So I need to do 32 divided by 89. 32 divide 89. Oh, no. 89. 30. Okay, so that is 0.359. So this is our percentage decimal multiplier for a reduction. Okay, so I'm going to first of all turn this into a percentage. So if I times this by 100, we know that this image here is 35.955% of the original image. Okay, so we need to know what percentage of the original width will the photo be changed to be. Okay, fine, so it's going to be changed to be 35.95%. So I think we could probably call that 36%. Yeah, there we go. It's not asking what percentage it's reduced by, it's just asking what percentage it's going to be. So it is going to be 36% of the original width. Let's check that out. Okay, here we go. 35.955016. Okay. Yeah, they haven't rounded it, so we probably actually needed to give this whole answer. That's interesting to know. Right, so there we go. Let's go back to the question. Right. Okay, so there we go. So they wanted more of that. Okay, just something to remember there. Right, let's have a look at the next question. So here we go, we've got question 8 here, and it says here that an estate agent needs to know the area of the plot of building land. The plan shows the building land. The scale is 1 to 1,250. What is the area? Right, okay, whenever you get area scale questions like this, you've always got to convert your measurements first and then calculate the area. So this is a rectangle. So the rectangle will be length times width. So the area of a rectangle is length times width. So we need to find out what the length and the width are of this. So the scale is 1 to 1,250. So I'm going to write that down here. So it was 1 to 1,250. And so we've got 16 here. So 16 is 16 lots of this scale. So we've times that by 16. So we need to times this by 16 as well. So let me get the calculator out. Here we go. I'll move it over here for this one. So we have got 1250 multiplied by 16. And that's 2,000. Okay, so that's nice. So that's the new width. So that would be 2,000. Well, that's 2,000 millimeters. Because the scale, when you have a scale like this, the units are the same throughout it. So that's 2,000 millimeters. So we will do something with that soon, but not just yet. Let's find out the length. So the length goes to 66. So basically we want 66 lots of 1,250. So I'm going to now do 66 times 1,250. So this equals 82,500, and that is still millimeters. 82,500 millimeters. Okay, right, so let's make these measurements more meaningful, because you'd never measure an area this big in millimeters squared. So, oh, they want it in meters squared. Okay, so let's do the 2,000 first. So 2,000 millimeters. To go from millimeters to centimeters, we divide by 10. So this becomes 200 centimeters. To go from centimeters to meters, we divide by 100. So this is 2 meters. So the width is 2 meters. Now let's do the longer one. So 82500. So this is millimeters. So for centimeters, we knock off a 0. So that's 8250 centimeters. And then for meters, we divide it by 100. So it goes to here. So it will be 82.5 meters. Okay, great. There we go. So we've got the length and the width. Now, as we discussed, the area of the rectangle is length times width. So I just need to times these two things together and make a note that I'm doing that, just so the examiner can see what I've done in case I go wrong. So here we go. 2 times 82.5. And this equals 165 meters squared. Okay, right, let's double check, because there was loads of space we could have gone wrong there, but hopefully we haven't. Yay, there we go, 3 marks for 106. Oh, have I gone wrong? I have gone wrong. Where have I gone wrong? I don't have that 0. They've got 1,650 and I do not. I've got 165. Oh no, let's go back and look. Where have I slipped up? Where have I slipped up? I think this looks like the likely place where I might have slipped up. Let's just double check that calculation. So get my calculator back. 66 times 1,250. 82,000. Okay, that's fine. This was 2,000. Oh no. I go into a rabbit hole when I do this. Right. So 2,000 millimeters is 200 centimeters, which is 2 meters. This is true, this is true, this is true. Let's double check this mark scheme again. Sorry. I've 20 and 85. Right. Have I got... How have I... So I haven't... So it's the 20 meters that I've gone wrong with. Let's just double check this. So 1 times 16 was 16. Let's get the calculator out. It looks like I've just missed a 0 here. 1,250 times by 16. Yes, I've dropped a 0. There we go. I'll put this in red. 0 here, 0 there, 0 there, 0 there, 0 there. And then there should have been a 0 here because that would have been 10 times bigger. Right, there we go. Sorry about that. Let's continue. So, next question. Question 9. An architect designs a shop refit. The architect needs to work out the weight of an oak panel. The oak panel measures 0.06 metres by 0.9 metres by 1.5 metres. The density of oak is 700 kilograms per metres cubed. Work out the weight. Okay, so just to make a note here, the density, they've given us the units for it. They've said that the density is equal to 700 kilograms per meters cubed, okay? Which means that it's kilograms divided by meters cubed. So this is our formula for how we calculate density. So density equals mass divided by volume, okay? Density equals mass divided by volume. Right, perfect. So, now that we've got that bit of information, we can continue with the question. So, an architect designs a shop refit. The architect needs to work out the weight of an oak panel. The oak panel measures 0.06. Okay. What is the weight of the oak panel in kilograms? Right, so we can work out the volume, okay? So the volume of well, it's going to be a cuboid because that's the dimensions they've given us. The volume of a cuboid is by doing length times width times height. So we're going to multiply these 3 dimensions together. So we're going to do volume equals 0.06 times 0.9 times 1.5. Okay, so let's do that on the calculator. So here we go, we've got 0.06 times 0.9 times 1.5. And that equals 0.081 meters cubed. Okay. We know that density is kilograms divided by meters cubed. Okay, we got that earlier. Let me just move this bit here. Let me just move this out the way so I've got some space. I'll leave it here though. Oh, so density. Ooh, I didn't take the Y with it. So density is this. So we've now got the density. We know that density is 700. So 700 equals the mass, which is the weight, so it equals the kg, divided by the volume, which is 0.081. Okay, now remember this sign means divide, so 700 equals kg divided by 0.081. Okay, so if that's the case, that means that the kilograms will equal 700 times 0.081. Okay, so here we go. 700 times 0.081. Here we go. So that would be 56 kilograms. 56.7 kg. I'm a bit nervous now about checking my answers after the last one. Let's have a look. So here we go. 56.7 kg. Perfect. Right, I am back on track. Okay. Right, let's go back to the next question. So here we go. The next question is question 10. A cook needs to cook a turkey to be ready by 6 p.m. The cook will start cooking the turkey at 1:30 p.m. The turkey needs to be cooked for 45 minutes per kilogram of total weight plus 20 minutes and then left to rest for 45 minutes. Okay. The cook has a 4.4 kilogram turkey. Has the cook allowed enough time? Explain. Okay, so we need to work this out. So the turkey needs 20 minutes just because, and then 45 minutes just because, which will equal 65 minutes, which is 1 hour and 5 minutes. 1 hour 5 min. Okay, so the turkey needs that much time without considering its weight. Now let's think about its weight. So it needs 45 minutes per kg of weight. So I'm actually going to start working here in decimal time. Okay, I'm going to go into decimal time because this is going to be much easier for this calculation. So 45 minutes is 45 minutes of an hour. Okay, so it's 45 out of 60. 45 out of 60, we actually also call this 3/4. It's 3/4 of an hour. 3/4 means 0.75 as a decimal. So we know that for every kilogram, we get 0.75 of an hour. So what I'm going to do here is I'm going to do 4.4, which is the number of kilograms we have, multiplied by 0.75. Okay, I'm going to get the calculator to do that. So here we go, 4.4 multiplied by 0.75. And this equals 3.3 hours. So this is 3.3 hours. Okay, so I'm going to just bank the 3 hours there. So we need 1 hour 5 minutes. We need 3.3 hours. Let's work out what 0.3 of an hour is. Okay, so 0.3 of an hour is 0.3 of 60. So we need to do 0.3 times 60 to convert that back into minutes. Okay, 0.3 times 60 equals 18. So we've got 18 minutes here as well. So we can then collect all of this together. So we've got 3 hours, 4 hours, and then we've got 5 minutes, 18 minutes, which makes 23 minutes. So 4 hours, 23 minutes is what she needs. Has she left enough time? Yes, she has, because 1:30 to 2 is half an hour, and then 2 to 6 is 4 hours. So 4.5 hours, 4 hours, 30 mins is what she left. 4 hours, 23 minutes is what she needs. So has the cook now given enough time? Yes, she has. Okay, so let's quickly check the answer. And here we go. Yes, 4 hours, 23 minutes. Okay, so that's what you needed to get all your marks. Okay, let's continue. So, next question. Question 11. A cafe makes its own coffee blend by mixing different coffee beans together. It uses Brazilian beans and Kenyan beans in a ratio of 4:1. The manager needs to mix enough beans to make 120 cups of coffee. Each cup of coffee needs 85 grams of beans. He needs to know what weights of beans to use. What are the weights of beans that he should use? Hmm. It's always, whenever you read these questions, there's always something to think about. So the first thing that I'm going to think about here is what is going to be the total weight of all of the coffee altogether. Okay, I think that's going to be the first thing. So I know that we've got 120 cups of coffee, and each cup of coffee needs 85 grams of beans. So I'm going to do 85 times 120 to find out the weight of the coffee. Okay, so let's get the calculator out. So here we go. 85 times 120 equals 1,200 grams. Okay, now I know that 1,000 grams equals 1 kg. And if I read this number in the thousands way, I would say that this number is 10,200. So I know that I've got 10,000 grams there. So if 1,000 grams is 1 kg, 10,000 grams is 10 kg, and this will be a 0.2 because that will just be carried through. So we have got, so this equals 10.2 kg. So this is how many kilograms of beans we need. Okay, so the next bit that we've got here is we've got to think about this ratio. So the ratio is 4 to 1. So that's, remember how ratios works, that's 4 parts to 1 part. So 4, well, we can think about these as bags of coffee, 4 bags of coffee to 1 bag of coffee. Okay, so altogether, when we're dividing a ratio in 4 to 1, we're dividing it into 5 parts. So we know that the 5 parts of the ratio equal, need to equal the 10.2 kg. If I divide this by 5 to get 1 part, I can divide this by 5 as well. So 10.2 divided by 5 is 2.4, well 2.04 kg. Okay, so the Kenyan beans, they only want 1 part 4. So that's the answer to the Kenyan beans, 2.04. Now the Brazilian beans is the rest, so we could either do the 10.2 take away the 2.04, or what I'm actually going to do is I'm going to times this by 4 because that's how many parts they get, and this equals 8.16. What I can do now though is add these together to check that they make the total amount of coffee. So add 2.04, and this should make the 10.2. Yep, great. Times this by 1,000. That will take us back to our calculation here, 1,200 grams. Okay, and that is that question done. So let's do the quick check again. Here we go. 8.16 and 2.04. Perfect. Okay, right. Let's continue. So here we go. The next question here is, oh, it's got a graph, and we can just about fit it all on the page, so that's good. So let's have a quick read of this question here. And the question says, a man is 185 centimeters tall and weighs 98 kilograms. He wants to reach a healthy weight. A doctor says he can lose 0.75 kg a week if he follows a diet and exercises to burn 600 calories per week. Okay. He plans his diet and decides to use yoga exercise to burn 600 calories a week. He will use one yoga class to burn 200 calories. Is that all you burn in a yoga class? Right. I feel like when I've done yoga, it's more. He will use 1 hour yoga class to burn 200 calories. Each class costs £6. He has £360 he can spend on yoga classes. This is a lot going on. Right, and let's see what the question is. Does he have enough money to pay for all the yoga classes that he's going to take? Explain your answer using figures. Oh dear. Right. So there is a lot to think about here. a man is 185 centimetres tall. I feel like we've got to use the graph for this. So 185 centimetres tall. Right, if we look at these bits here, we can see that 2 centimetres is 5 squares. So 5 squares equals 2 centimetres. So 1 square, well, actually, so we need to work out what 1 centimetre is. Well, 1 centimetre will equal 2.5 squares, okay? So 185 comes in here. So let me just draw a line across here so we know what we're looking at. Oh, I was hoping that would straighten out. Here we go. I've gone a bit low. Okay, 1 second. Let me just move this up a little bit. Just to here. Right, there we go. So, this is here. I'm guessing we're using this to work out the healthy weight. So does he have enough money to get to a healthy weight? That's what he's saying. He's got £360 to spend on yoga classes. Can he get to a healthy weight? So he needs to get to, if we're going to assume that he's just on the cut, well, let's go here. So this looks like 80. Oh, so here we've got 5 squares representing 10. So if we've got 5 squares equals 10, then 1 square equals 2. Okay, so his healthy weight looks like it's bang in the middle of here. It looks like his healthy weight is 85 kg. Okay, so his healthy weight is going to be 85 kilograms. Right. What is he currently? 98 kilograms. So he needs to lose the difference between these two. So he needs to lose, we need to do 98, take away 85, and that will tell us what, that's going to be 13. So he's got to lose 13 kg. This is the big question. He wants to lose 13 kg. Okay, let's now work out how long that is going to take. I'm not going to think too much about the yoga just now. I'm going to just think about this. He loses 0.75 kg a week. He wants to lose 13 kg. So we need to know how many weeks of 0.75 make up the 13. So we need to do something times 0.75 equals 13. Okay, so we need to see how many weeks that is. So how many weeks gets us there? So what we're going to have to do is we can do 13 divided by 0.75, and that will tell us the number of weeks. So let me write that up here. 13 divided by 0.75, and let's work out that on the calculator. So 13 divided by 0.75 is, oh gosh, 17.3 recurring. Okay, so that's going to be 17.3 weeks. Well, I guess we'll have to say that's 18 weeks. Okay, right, so 18, so it's going to take him 18 weeks to get there. So I've put that up there. Now let's think about these yoga classes. So, okay, right. Oh, we're home and dry. Right. He will use 1 hour yoga class to... Okay, right. Let me just check the question again. So, does he have enough money to pay for the yoga classes? So he needs 18 yoga classes. Okay, so 18 times the £6. Okay, is that right? Oh, he's going to be fine, I think. 18... 18 times 6. I don't feel like I'm doing this question correct. 18 times 6. I think I've read something wrong here. Right, I just need to go over this question. So he's got plenty. So according to what I've done, he's got plenty of money, but usually these questions are all on the cusp. Okay, so let's have a look once more at what he's saying. He says a man is 185 centimeters tall and weighs this. He wants to reach a healthy weight. A doctor says he can lose 0.75 kilograms a week if he follows a diet and exercises to burn 600 calories a week. He plans to diet and use yoga to burn 600 calories per week. Right, okay, this is the bit. Each yoga class burns 200. He wants to burn 600. So he's going to go to 3 yoga classes a week. Okay, so we're going to need to multiply our 108 by 3. Okay, so we're going to have to then... So this is the cost if he went once a week. So then we have to do 108 times 3 so that he gets to 3 classes a week. And that gets us a number much closer to 360. So 108 times 3 equals £324. So he has enough money to buy the yoga classes. Okay, I'm a bit nervous about this answer for this one. I feel like I've kind of gone convoluted. Yes, and a clear explanation relating to correct calculation. Yoga classes cost $312, okay? So I bought them 2 extra. So value between there's leeway though because there's different things. Value between 16 and 19 weeks, fine. Yep. Okay, great. We'd have got all the marks. Perfect. Wonderful. Let us move on. Okay, so here we go. Question 13. A house tenant has a budget of £75 to redecorate a room. The room has 2 walls, 2.98 metres and 3.94 metres long, and the wall is 2.5 metres high. Okay, I can understand it from the box. Okay, so this is the model of the bedroom. She wants to paint 1 long wall and 1 short wall. Okay, fine, she's only painting 2 walls. Okay, she wants to put wallpaper on the other short and long walls. So she's wallpapering 2 walls. Okay, so we've got 4 walls, 2 are being wallpapered, 2 are being painted. She wants to put wallpaper on the other short wall. A 2.5 litre tin of paint costs £16 and covers 30 metres squared. A roll of wallpaper is 52 centimetres wide and 10 metres long. Wow, these questions are long. Okay, can the tenant decorate the room for the budget set? Let's have a look. So, she has £75 to decorate the room. Let's work out the paint first, okay? So I'm going to do the paint first. So we've got the paint. So we need to calculate the area of the wall. So let's do the short wall first. So this short wall is going to be 2.65 times 2.98. Okay, get out the calculator. 2.65 times 2.98. So that equals 7.897 meters squared. So that's for the short wall. Let's do the long wall. Long wall equals 3.94 times 2.98. Okay, I'll do these. So 3.94 times 2.98. No, not times 2.98. That we want the height. Right, we need the height. We need these 2 measurements here. So we need the 2.65 times the 2.65. Okay, so here we go. 3.1 times 2.65. And this equals 10.441. Okay, there we go. 10.441 meters squared. So collectively, we can work out how much paint we need for both of those now. So if I add the other one, 7 0.897. And so that equals a total area. Well, it's the same for both of them actually. Total area equals 18.338 meters squared. Okay, a tin of paint costs £16 and covers 30 meters squared. Okay, so fine, the paint is good. We're good for paint. Okay, so tick. But we do need to remember that we've spent £16. Okay, but the paint is good. A roll of wallpaper is 52 centimeters wide and 10 meters long. Okay. Fine. Can a tenant decorate the room for the budget? So this is a bit more complicated because we've got to work out how many strips. Well, I guess, could we do it by just calculating the area? I don't know if we can. Maybe we can. It seems like the lazy way to do it. But we could work out how much area one wall of wallpaper. In fact, yes, we can, because you can cut wallpaper up and stick it as you will. So let's do it that way. So let's work out the area of one roll of wallpaper. So that is going to be 0.52 multiplied by 10. Okay, because 52 centimeters, 0.52 meters. So here we go. Let's do this calculation here. 0.52. Why am I using a calculator for this? I know that it's 5.2 times 10. I'm not showing off there. 5.2. So 5.2 meters squared. Okay, right. We need to get up to 18. So let's have a look. Well, we're going to have to go. One roll would be 5.2. 2 rolls would be 10.4. 3 rolls is going to be 15 point something. Let's times that by 3, see? 3 rolls is 15.6, so 3 rolls isn't enough. So let's try 5.2 times 4. We're going to need that 4th roll. 5.2 times 4. So that's... Yep. So 5.2 times 4 equals 20.8 meters squared. Okay. So we know that we need... That is enough wallpaper to cover it. So we know we need 4 rolls of wallpaper. The wallpaper costs £10 a roll. So that means we're going to have 4 lots of £10. So let's do the final calculation here. So we've got £16. £16 for the paint. And then we've got 4 times £10 equals £40. So £40 for the wallpaper. So £16 plus £40 equals £56. Now again, this isn't quite close enough to that 70 to make me feel 100% happy with this as a question. But let's just double check everything. So £75 to decorate the room. Let me get rid of the calculator. Sorry, that's in the way. £75 to decorate the room. Okay, great. We've got that. She wants to paint one long wall and one short wall. Okay, so we've calculated the areas of the walls. 2.65 times 2.98. Yep. Long wall is 3.94 times 2.65. Yep. Added together is this. Okay. The 2.5 litre tin costs £16 and covers 30 meters squared. So that is fine. We are good. The wallpaper, we've worked out the area of. Great. We know that we need 4 rolls at £10. And so that will be £56. Now, the only thing I'm worried about here is if we needed to actually work out how many strips of wallpaper. And I think we might have done, because an extra roll would take us up to 66, 76. I don't think we'd have needed 2 more rolls. Actually, we're fine. Yes. Anyway, we're low. We're way under budget. We've got enough. Let's have a look at the answer scheme. Yep. 16. Yep. 4 rolls of wallpaper. Perfect. Correct decision based on £56. Yay! Okay, great. That is wonderful news. Okay, let's move on. Question 14. So here we go. A vet nurse in a pet rescue centre records the weights and ages of kittens brought to the centre. So the weights and ages of the kittens are here in this chart. Okay. We're going to have to draw a scatter graph. So we're going to plot the weight against the age. Okay. So what we're going to do is we're going to have to plot these values in a table. One day the centre receives an abandoned kitten that weighs 460 grams. The nurse needs to estimate the age of the kitten. Use the trend line. Okay, fine. So here we go. I'm going to have to just zoom a little bit here to get this all on. Here we go. So what do we have? Okay, so we need the weight needs to go up to 720. Okay, but it doesn't need to start. Well, actually, it goes down to 180. So let's take it all the way to the 0. So let's see how many squares we've got to play with here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 squares, and we need to get to 720. You know what? I'm actually just going to make each square worth 100. Okay, I think we won't use all the squares, but I think that is a respectable scale. Okay, so we're going to use 2 squares for 1. Okay, so, and then I'm going to go along here. 2 squares for 1. So we're going to go here. This is 100, 200, 300, 400, 500, 600, 700, 800. I think that's what they wanted. Now here we need to get up to 56. Okay, so let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 56, 10, 5. I'm gonna... We don't have enough... yeah, I'm gonna make each one 10. So 10, 20, 30, 40, 50, 60. Okay, and now I'm just going to plot these points. So we've got here 50 and 600. So that would go here. 28 and 340. So 28 is here. 340 is here. Oh my gosh. 42 and 480. This is an annoying task. 20 and 360. 50 and 660. Here we go. 28 and 420. 20. Oh, we've already had 28 before. 28 and 420. 14 and 180. So 14. So that's 2 in 180 from the top here. Okay, great. We should label it weight, age, days. Okay, and grams. Oh, grams. They're so small. They're little kittens. Right, okay. So here we go. We can now plot our trend line. Remember, when you plot a trend line, you should use a ruler, and it should only really go through the data that you have. You can't really say anything beyond the data that you have because patterns stop outside of data ranges. Okay, so here we go. We've done that now. Draw a suitable graph and trend line. Estimate the age, the weight, the age of the abandoned kitten. So 460 is here. So we need to draw a line over to here. Okay, and we need to draw a line down to here. So this looks to me to be 36 days. Okay, there you go. So let's check that answer. There'll be some leeway for this one. Here we go. Oh, they use the same scale. That makes me feel good. They've gone for 35 days. Okay, I think they'd accept 36. They said e.g. 35, yeah. So 36 would be acceptable as well. Okay, great. Right. Let's move on to question 15. Okay, a city council wants to encourage car sharing to cut pollution. It takes a survey of cars entering the city to find these results. Okay, one second, let me just check them. Yep, so to find these results. So we've got the mean of 1.65 and we've got a mode of 1. It introduces a congestion charge for cars with only one person in. It wants to know if the congestion charge is effective in making people share cars. It takes another survey of the number of people in cars entering the city. Is the congestion charge effective? Well, it is. Because the mode has gone to 2. So the new mode is now 2. So that means that it's most common for people to have somebody else in the car with them. We will probably have to calculate the mean as well, just because that's the other figure that they've given. But I think it's definitely been effective. So the mode is now 2. And let's find the mean. This is a nice mean question. Oh, actually, it's a bit of a tricky mean question. We've got to work out how many people there were altogether and how many... How do we do this mean? So number of people in a car. Sorry, one sec. I just need the toilet. Sorry, I didn't mean to tell you that. Right. Sorry about that. Right. So, yeah, we need to work out the mean number of people in each car. So, we need to work out how many people there are, how many cars there were altogether, and then divide it by the number. So, we know that there was 17 cars with one person in. So, we need to do 17 times 1. We know there were 54 cars with 2 people in. So we need to do 54 times 2 to find out how many people there were in those cars. Then we need to do 14 times 3 to find out how many people were in the 14 cars with 3 people in. Then we need to times this by 4, times this by 5, and then that's a 0, so it doesn't matter. Okay, so we can work out these, and that's going to tell us the total number of people that travelled in by car. So let me get out my calculator. So here we go. Well, 17 times 1 is 17. 54 times 2 is 104. 14 times 3 is 52. 8 times 4 is 32. 2 times 5 is 10. Okay, and then we can add these all together. So, 17, add 104, add 52, add 32, add 10. And that equals 215. So there was 215 people. Okay. Now we need to add up how many cars there were. So we can add up this list here. Okay, so we do 17, add 54, add 14, add 8, oh no, 14, add 8, add 2, okay, let's just double check those numbers. So there's now 95 cars. Okay, so there's 95 cars and 215 people. So if we do 215, divide 95, we'll get the mean number of people per cars. So 215 divided by 95 equals 2.26. Okay, right, so we've now got our mean, we've got our mode, and we can definitely conclude that the system was effective. So let's say, yes, show you're working. So mean equals 2.26. Mode equals 2. Comment 1. The mean number of people per car has increased. Meaning less solo drivers. The new mode is now 2, which means most people are sharing a car. Okay, right, and we can check that with the mark scheme to see what they wanted there. So here we go, 2.2 for mean, perfect. And then 2 identified as the mode. Correct comment to say that the new mean is higher and the mode is higher as well. And that is the last question. Excellent. Okay, perfect. So, right, very nice. So we're all done. Okay, brilliant. Well done. I hope that that was useful for you this week. Remember, there is loads of stuff over at Crack Maths on the website. In fact, let me take you there right now just to remind you. If there's any topics there today that you... oh, no, this is the wrong section. If there's any topics that you wanted to look through from today, there are tutorials on absolutely everything you need to know. I've kind of bunched them into groups here. But you can click on them. So say, for example, you wanted to have a look at some more handling data questions like we've just done. Here we go. We've got a topic here, how to estimate the mean from a group frequency table. So here, this will, if you scroll down, oh, where is it? Here we go. How to estimate the mean from a group frequency table. So here is there's a video that explains that, and there's a bunch of questions here. And always remember that if you go to the end of these questions, you can find the answers that are there as well, so you can mark that. If you also get the time, if I know it's a bit weird to ask, but if you could like or comment on any of my videos, that would be really great, because that would be really helpful. Next week, I don't have a live session planned because it's half term. But what I'm going to do from the new time, I think I'm going to change to doing topics again. So I'm going to bunch together different topics that exist and try to level up the practice questions that I've been doing, just to make them a bit more similar to the exam style and to make them more challenging to help yourself get through them. Anyway, I am going to leave it there. So thank you again so much for joining me, and hopefully I will see you in a couple of weeks. Okay, cheers, bye.